Hi guys, today we're going to work on IXL assignment WKM, solve one-step equations. Let's refresh our memory real quick before hopping into IXL. Whenever we solve an equation, the first thing we need to do is identify the variable. So identify that letter and what operation is going with it. So in this example, we have X and we notice that 12 is being added to it. The whole purpose, the whole goal of solving the equation is to isolate our variable because we want to isolate, we want to get that variable all by itself. So then we know what it's equal. We know, hey, this variable is no longer unknown. I know that it equals a certain amount. In order for us to do that, we always use the inverse operation. So operation is like adding, subtracting, multiplying, dividing. And then inverse, well, if you take the inverse of something, it's like the opposite of it. So if we look up here in the corner, addition and subtraction are inverses. They're opposite of each other. So they undo one another, as are multiplication and division. So once you identify your variable and you identify the operation, so in this case, 12 is being added to it, then we know, okay, to isolate that X, to get that 12 over to the other side of the equal sign, we need to do the inverse. The inverse of adding 12 would be subtracting 12. So we are going to subtract 12 to move it over, to isolate that variable. With an equation, we have to keep it balanced. So whatever we do to one side, we have to do to the other. So if we're subtracting 12 here, then we need to subtract 12 from this side as well. So 12 minus 12 is 0, which just leaves us with our X. And then 33 minus 12 is 21. So we just solved that equation and said, all right, X is equal to 21. The cool thing about equations is you always have the ability to check your work, to do a double check and say, did I get this right? You can check your work by substituting or plugging your answer back in. So if we think about our original equation, we just said, hey, X equals 21. So we can put 21 in for X. 21 plus 12 is in fact 33. So we did everything correct. Our work checks out. All right, let's head on over to IXL so we can get a lot of practice in and you can see a variety of examples. Here we are on IXL and we are working on assignment WKM, solving one-step equations. Here we have our first problem, solve for J. I'm going to rewrite it over here so I have room to show my work. So 3J is equal to 6. The whole purpose, as we're told, is we want to solve for J. We want to find out what the value of that variable is. So it needs to be all by itself. It needs to be isolated, meaning we got to get rid of that 3. Well, what's the operation? What's going on between the 3 and the J? Remember that when you have a number and a variable side by side like that, that is one of the ways we can show multiplication. We currently have 3 times J. When we solve equations, when we're trying to move something to the other side, we always do the inverse. What is the inverse of multiplication? Division. So in order for us to isolate that J to get the 3 to go away, we are going to divide both sides by 3 because we have to keep our equation balanced. Whatever we do to one side, we have to do to the other. 3 divided by 3 is 1. So we're just left with the J. And then 6 divided by 3 is 2. Now, let's go ahead on this first one and check our work just to make sure we did it correctly. Remember that we can check our work by substituting, by plugging that 2 back into our equation for J. So instead of 3 times J, well, we just said J was 2. Is 3 times 2 6? Yes, it is, which means we did our math right. We are correct. All right, this one's pretty similar, so let's find one that looks a little different. All right, guess not. We'll go ahead and solve this one. All right, we want to solve for Q. So 4Q equals 12. All right, we want to isolate that variable. We want to get it by itself. We want to get this Q by itself. So what's going on with it? Well, sometimes, especially when, we get a little bit more practice and we get farther into equations, it may be hard to see what's on the same side of the equal sign as your variable. So something I like to do is draw a line down my equal sign because that separates the two sides. So I can focus in, I can zero in on that variable and say anything else that's on the same side as the variable has got to go. I got to use the inverse to get it to the other side. And I notice that I have a 4 being multiplied by my Q. Whenever we move something to the other side, we must do the inverse. What's the inverse of multiplication? Division. We are going to divide both sides by 4. And we have to do it to both sides to keep our equation balanced. 4 divided by 4 is 1. So we're just left with a Q. 12 divided by 4 is 3. We have solved for Q. We know exactly what its value is, which means we're done. This is a good one. It looks a little different. 15 equals J minus 4. All right, you might be getting to this point depending on how, your brain works. And you might be like, Mrs. Ailstock, I don't need to do those steps. I can just look at it and figure out what the answer is. If you can do that, that is awesome. But I want you to listen to this. Sometimes when you get negatives involved, that could throw you for a loop. And also, when you get longer problems, it gets to the point where you can't do it all in your head. So therefore, if you're like, I think I know what the answer is, this is the perfect opportunity for you to practice those steps and see if you really were right. Because by practicing those steps, it'll help you when the problems get bigger and you will have a good foundation built and you'll be like, I know how to do this inverse operation thing. I got it down. Okay. Now that I got off my little soapbox here, let's finish this up. Once again, I'm going to draw an equal sign down the middle so I can, or a line down the middle of the equal sign so I can see the difference between my two sides. I want to find what J is. Well, on the same side of my equation as J, I have a minus 4. That needs to be moved. We always do inverse operations when we're taking something to the other side of the equation. What is the inverse of subtracting? Adding. We are going to add 4 to both sides of the equation. 15 plus 4, 19. I bring down the J. Negative 4 plus 4 is 0. So that zeroes out, and we are left with 19 equals J. It is okay that your variable's on the other side. It still is telling us that J represents is equal to the number 19. That is what will make this equation true. All right, how about this one? 5z equals 80. Our numbers are getting a bit larger, but I still encourage you guys to try to do it in your head or work it out on paper. But because, you don't want to miss it, you could double check your work in a calculator, but do try to do these without first. 5z equals 80. Let's draw a line down our equal sign so we can visually see the separation. We are trying to solve for z. Well, 5 is being multiplied by z. That 5 is in the way of us knowing what it means. To get rid of that, to get it to the other side, we do the inverse operation. The inverse of multiplication is division. We will divide both sides by 5. 5 divided by 5 is 1, so we're just left with 1z. And what is 80 divided by 5? 16. And that's one that you may not know off the top of your head. So remember, that's when you can set up your division problem. 80 divided by 5. 5 can go into 8 one time, with 3 left over. So 5 can go into 30 6 times, and looky there, there's that 16 that I just got. All right, when you get a little bit higher, that is when you might start to see some negatives. But you do want to be careful to follow those integer rules and make sure that that doesn't cause you to make a mistake. So we're going to copy our problem down. W minus 867 equals negative 399. Even though my numbers are larger, still the same process. I draw that line down the equal sign to help me visually separate it. Read the directions. We are focusing on solving for W. So W is what I need to isolate. Right now, on this left side of the equal sign, we have W minus 867. What is the inverse of subtracting something? Adding. We are going to add 867 to both sides. We bring our W down. Negative 867 plus 67 is 0. Now we have negative 399 plus 867. Definitely can't do that in my head. I'm going to need to work it out. Remember, when we are adding and subtracting, if your signs are opposite, like this, we have a negative and a positive, you subtract them, and the larger absolute value is the sign that you keep. So first, let's subtract them because they have opposite signs. We're going to need to do some borrowing here. So 17 minus 9 would be 8. Can't do 5 minus 9, need to borrow again. 15 minus 9 would be 6. 7 minus 3 would be 4. Now, to figure out your sign, when you talk about absolute value, remember that's the distance, so the positive version of your number. 867 is larger, and that number is positive, which means our answer is a positive 468. Awesome. Let's go ahead and try this one. These are pretty quick. We'll try to do lots of examples, so if you need to keep watching it, you can see, okay? K plus negative 25 equals negative 898. Draw that line down the center so you can see the two sides. We are focusing on solving for K. Well, we have K plus a negative 25. What would be the opposite of a negative 25? A positive 25. We are going to add 25 to both sides. We bring our K down. Negative 25 plus 25 is 0. And now we're in a similar situation where our numbers have opposite signs, a negative 898 and a positive 25. So we're going to subtract them first. And then the absolute value that is larger is the sign we take. 8 minus 5 is 3. 9 minus 2 is 7. And we bring down our 8. Well, if we look at the absolute value, so the positive version of our numbers, 889 is bigger. And that number was negative, which means our answer will be a negative 873. Please be careful and watch those negatives, because that is definitely something that can trip you up. All right, this will be the last example that we do together. 200 is equal to V minus a negative 37. First off, let's draw that line down the center. Now, this is the first time we've had one like this. We have minus and negative. That isn't simplest form. Therefore, we need to simplify that side first before I can determine that opposite operation. Remember, when you have minus, you do the keep, change, or maybe you realize if I have minus and negative, I can't have that double negative. It becomes a positive because minus and negative, opposite is a positive. Now that we have simplified that and we really know what our sign is, we can do the inverse operation to get V by itself. We have V plus 37. What's the inverse of adding? Subtracting. You're going to subtract 37 from both sides. 200 minus 37 is 163. We bring our V down. 37 minus 37 is 0. And we have solved our equation and found our value for V. All right. So it is your guys' turn to try. Be careful. Double check your work. Show all your steps like I did so you can build those good habits. So in our future lessons, when the problems get a little bit longer, you know what to do and you can be confident and rock equations. All right, if you guys have any questions, send us an email, come to a help session, and we'll be happy to work with you. Bye.